Hi everyone, this will most likely be my last video of the year, and this will be explaining the last three problems from section 5.4, most recent homework assignment on page 402. So let's start with number 37. It says find the exact value of the expression. So when I look at this, right away I see sine of pi over 12. That is a value that I don't know from the unit circle. But when I look at this format, I see sine of some angle, which I'm going to call u, and then cosine of another angle, right? And then cosine of the same one from the beginning, and then sine of, again, the first part, which is the v. Okay, so when you look at this formula, this is sine u, this is cosine v plus cosine u sine v. So check out the formulas. Which one is this? This one is the sum of sine. Okay, this is what this is equal to, right? These two things are equal. Okay, so therefore, all you had to do here was insert your u, pi over 12, your v, pi over 4. Now, obviously, when we have to find a common denominator here, so this guy right here is going to turn into 3 pi over 12. And then adding that to pi over 12 is going to be sine of 4 pi over 12, and that will reduce to sine of pi over 3. So what is the value of sine of pi over 3? Again, always go back to your unit circle. Here's pi over 3. And what's the y value there? That would be radical 3 over 2. Okay, so that is number 37. Okay, moving on to number 59. And obviously, you know, this is a video, so if anything is too fast, feel free to pause, rewind, and all that stuff. Okay, so in number 59, we're given an expression. Okay, so this is a little bit difficult and different because we don't have actual values this time. So again, go back to your formulas. This would be u and this would be v. So this is cosine of u plus v. So using the formula, I'm going to plug in these u and v values. So this is going to look like cosine of arc of u, which is arc cosine x, and then I'm going to run out of space probably on this line, but it's okay. Cosine arc of v, which is arc sine x, minus, because again, this is the formula, I'm going to have to go on the next line, sine of u, which is arc cosine x, sine v, so sine of arc sine of x. Okay. Now we have to simplify this. So right here, let me use a different color. In the beginning right here, from our inverse property, we know that that is just going to be x. Okay. Now this guy here, I'm going to have to draw a triangle to figure this out. So first, I'm going to use this information, arc sine x. Okay, that means that if I draw a right triangle, and I'll do it over here just to, oh, that's terrible. Let me try a little bit better. Okay, so let me just draw a triangle. I really don't think that's much better, but work with me here. So here's an angle, so sine is opposite, so x over hypotenuse, 1, because technically this is over 1. So now I'm going to use my Pythagorean theorem to find out what this is, our adjacent, because cosine is adjacent over hypotenuse. So really what I'm looking for is this side right here. So I would do x squared plus b squared equals 1 squared. And that would be x squared plus b squared equals 1. Subtract my x squared to both sides. B squared equals 1 minus x squared, square root that. And so my adjacent is square root of 1 minus x squared. So when I'm asked for cosine, right here, that is going to be adjacent over hypotenuse, which is just square root of 1 minus x squared. Okay, minus, now I got to do this right here. But we already have this information here, so I'll just draw another triangle to clear it up. So again, here's your angle. Now it's the inside says arc cosine of x over 1. So x is your adjacent. So now again, doing all of these steps right here, you'll see that now the opposite is 1 minus x squared. Square root of 1 minus x squared. So altogether, that's what this is. And then this part's easy because these signs will cross out, and that's just x. And now we'll simplify this just to have it in front, you know. Okay, and now look, we're subtracting the same thing. So our answer is just 0. Okay, so again, 59 is a little complicated, I know. And now we go to the last problem, number 61. So 61, it says to prove the identity. So it says sine pi over 2 minus x equals cosine x. Okay, so remember, when you're proving identities, you always go to the more complicated side first. So that would definitely be right here. We can't really do much with cosine of x. Let me use a different color. So right here, this is, again, just applying the formulas. So if you look at your formula for the difference of sine, I'm just going to insert these values. So that would be sine of pi over 2 cosine x minus cosine pi over 2 sine x. Unit circle, sine of pi over 2 would be 1. Cosine x is going to come down. Minus cosine of pi over 2 is 0. And then sine x. Anything times 0 is just 0. So as you could see right here, 1 times cosine of x is just cosine of x. And so we have proven the identity. Yay. All right, guys, hope that helps.